Oh, we're here?
Thank you.
Okay. So welcome everyone to our first official meetup slash Red Hat user group event for 2018. Thank you for coming. And we're excited to talk about one of our hottest topics, microservices, Kubernetes, Docker, Istio, everything. So we're really excited to have a fun event tonight. As you can see, there's a lot of things to contribute to. We're going to have some wonderful raffles at the end. So the more questions you ask, the more tickets you get, supposedly. But anyways, more importantly, we are here to talk about a topic that's of interest to everybody. So without further ado, I will let Nate and Karthik kick it off.
Sounds good. Just a quick audio check, guys. Is anyone on the Zoom right now? Because I think it came out okay, but I think this mic is a little bit better.
Sit here.
No,
Hello.
People say I have a radio voice sometimes, so it depends on which one you go.
This is how you get out of your comfort.
What's
Yeah,
that?
we have a nice new
We do,
audio
we have
system
one
here.
online.
It's working.
Always free microphone singing down. And like I said earlier, if I stand, then you have to stare at me because we couldn't figure out how to get to the thing over there, so I'm just going to sit. We'll be one of the guys. So yeah, like Karthik said, some of the hottest things out there right now are anything cloud native application development, Kubernetes. That's going to be one of the questions later, so make sure you know what Kubernetes is. Istio, something that's up and coming with regards to service meshes, and Openshift, which is the Red Hat Kubernetes product. So as we go through all this stuff today, we want to make sure we cover the what, why, and the how of cloud native app dev. So we'll just do a quick level set with that. We're not going to get into the down and dirty details, but we do want to make sure we're all talking about the same thing. We'll talk about how Openshift helps enable cloud native app dev. And you'll hear me a lot today whenever I say Openshift. I generally will also mean Kubernetes at the same time. They become kind of synonymous because Openshift is Kubernetes. Everything you can do in Kubernetes outside of really early alpha features, you can generally do with Openshift. So you'll see me go back and forth with those a lot. And then I'll turn it over to Karthik, and we'll talk about how Istio can take a lot of this stuff to the next level.
Is OpenStack sort of works with OpenShift? How does it
OpenStack is infrastructure as a service, so we're not really going to be talking about that today, other than we might mention infrastructure a couple of times, and OpenShift can run on OpenStack. OpenStack's going to provide a virtual machine, and then OpenShift will kind of take over from there. The same way AWS will provide an EC2 instance. Or
you have to use
server.
multi-user interfaces to come up with a project?
I don't really need.
You have to use OpenStack.
Oh, if you want to provision like an OpenStack instance and then install OpenShift on that instance, generally you would have to use two separate interfaces unless you put like an Ansible playbook together to go and do all that for you, which is probably what you would want to do in the end game. But if you're just playing around and starting something up, you have to use two separate ones. They talk to one another.
They don't overlap at all. Okay.
You don't need to have OpenStack to have OpenShift.
But if you are doing OpenShift on OpenStack, you still have to talk to them. The OpenShift user interface and the OpenShift user experience is really geared towards developers, right? It's not necessarily geared today towards the operators of the platform in the cluster. That's something that's coming with the CoreOS technologies from the recent acquisition. But right now, if you log into OpenShift UI, and I'm not sure if you'll show the UI in your demo or not, so you'll see a little bit of the UI there. You'll see it's very developer focused. How you use the platform, not the platform. Because at the end of the day, no one builds a platform just to build a platform. We build it so the business can do something with it. But anyhow, Karthik will take over with the Istio stuff. We'll show you how the early stages of Istio integration with OpenShift. All right, so the cloud native app stuff, right? Whether disruptions everywhere, we all know that. Whether it's the new guy, whether it's the old guy, whether you are the new guy or the old guy in the room, it's a reality, and we all have to be faster and adapt our business quicker. And cloud native app dev is all about becoming faster. right? So we need to increase the speed of delivery for our applications, updates to existing applications, regardless of whether they're new, old, on-prem, cloud, it doesn't really matter. We need to increase the speed of change faster so we can adapt to new user behaviors or new technologies on the market. We need to increase the speed of development faster to take advantage of those same opportunities that appear out there. And most importantly on this slide, we need to innovate faster, right? So we need that experimentation culture to take the newest thing, try it quickly, fail fast, to overuse that term, and have that quicker feedback loop to adjust on the fly. So even though we need to, we all know we need to move faster, getting there is not necessarily something that's going to happen overnight, right? It's a little bit of a journey to that cloud native nirvana. Starting with the reorg to a DevOps type culture, in practice, not just in name. When you go to a company and they have an ops team that's been around for 20 years and they've relabeled them DevOps, not quite the same as actually having a DevOps team that can kind of do both things relatively well. I came before my days at Red Hat. I was in one of those companies that was 100 years old that they would tag a operations team. It was a little bit more forward-looking. They're like, the new DevOps team, don't worry. They're kind of not. We don't really know what we're doing. So, but that true organization reputation of DevOps. And then all these steps in between, right? So we need to automate the deployment of the infrastructure, whether we're using public cloud resources, whether we're using OpenStack, or something in between. We need those CI/CD pipelines. We need to embrace advanced build and deployment techniques, and then eventually get to this. In a lot of cases, Nirvana microservices or mini services or some form of modern application architecture. So we need to move faster. We know where we need to get to embrace cloud native applications, but to frame the rest of this conversation today, we want to make sure we all understand the characteristics that define a cloud native app, right? So service-based, could be microservices, could be mini services. It could still be a monolithic application the way you deliver it, but underneath the covers, it's still a little bit more modular and loosely coupled. So service-based is a requirement. API-based, so no form of inter-process communication other than API calls over the network. So no access to another team's data stores, no memory sharing models. If you're not making API calls to talk from one service to another, it's really not a cloud native application. Containers, they're the execution environment. They're the immutable object. If anyone ever played World of Warcraft, the immovable object, or even Warcraft? You never know, right? They're the immutable objects, right? So they're the way that you get your great idea out there quickly and roll it back just as quickly when it doesn't work the first time, without taking down full VMs or servers to do it. And most importantly, the DevOps automation piece. So implementing the processes, practices, instrumentation to take that new idea, from development to test to production and ultimately start to make the company money.
Wait,
No.
You don't have it. You gotta roll back a tape. Roll back. So, in the beginning, we kind of joked that people thought that doing this was all it took, and you were kind of cloud native at that point. Look, I can do a Docker build and a Docker run, and I have an application, and I'm ready to go. And it seemed really easy.
I have a question on rollbacks. So you put in a new version, and you just say you put in one host, the new version. But if it doesn't work, I mean, you're making quite a few people angry. And so it's best to make sure it works without even trying it in production. So
Sure.
Saying you can roll it back if it doesn't work, it doesn't seem like a good way to go for just under my way of thinking.
So we'll talk about this a little bit more in detail later on, but right now, just to give you kind of a quick answer, number one, in the earlier environments, you're not going to go directly from a code commit to production. There's still going to be some degree of testing in the, whether it's a test environment or a dev environment, but when you get to production, there could still be some problem. Maybe the user doesn't like a certain color, so you still want to be able to roll that back, and this is the part we'll talk about earlier. When you move that new version into production, maybe you only move 10% of the traffic over there to get a feel for it first. So you're not taking down or pissing off your whole population. you're moving little bits and pieces over, testing it,
So,
and
yeah,
it's failing. Then
it's
you're
half the thing that are not critical.
And in fact, this is one of the demos I'll do is like a generic subject one where you can actually have a small subset of users going to the new.
Right, and my argument against that, you should have a right before you ever try to test it.
But
And even if you bring up one or two, no matter how you do it, I mean, you're making a lot of people mad.
I think the key is you have to evaluate what those risks are and what you're willing to trade it off for.
Right.
So yeah, you can run into situations where you make a lot of people mad, but if that's okay in your business model, or if depending on what's coming into it, you have different
risks
try
and rewards,
algorithms
right?
and everything. And then,
You could take 6 months or a year to get it just right,
Yeah.
and then you're behind the other guy that failed once, but he was right the next day.
It's just that's the first time I ever heard a comment like that.
Or the idea that you must have a test, dev, QA, production set of environments where you roll your code through those phases, and then when you get to production, you'll never have that.
Yeah, that's good. Yeah, I like that.
In the earlier part, you're doing unit tests and integration tests and stuff like that, and that's just to make sure it works, so you don't piss people off, the whole platform dies. And then when you get to production, like I said, they may not like the color, but it's not going to probably upset your whole population of your user base. So there's still iterations to go through.
Many companies also try to deploy the Windows where they have a low traffic. That's like an assessment that they do. They roll it out, during low traffic time, so they can quickly correct it.
But these, to me, these are valid, but these are also the old way of doing it during low traffic time. Who cares if I want to push it out in the middle of the day, as long as I'm only moving 1% or 5% of traffic over there. Let me do it.
Like this is have fun, facing off our thing.
Sure.
That's one way of addressing the situation, but you don't want to stay behind, not doing it or taking a longer time.
I don't know. I think it's, and we talked to a lot of customers, and it's riskier to not move quickly and not take that chance nowadays than it is to do it the way a lot of us were used to doing it for a long time. So
You mentioned the fail fast model, right? Doesn't it fit into this?
the fail fast model.
Yeah, pretty much. We want to fail first, as fast as you can.
And you get that immediate feedback. And if you have the right mature pipelines and everything else, you're adjusting like that. And if you have the platform and the tooling to help you fix that color because it's the wrong shade of blue, then you still got all the cool stuff out there or the wrong shade of red. Then you adjust that. Should have done red. 2 swings and 2 misses. Blue, green, red. There we go. So people started thinking this was, hey, we're cloud native, we're doing Docker containers. It was maybe a little bit more like this, right? A developer put some code in a source repo, went through some CI/CD engine, spit out a container, and it ran on the server. But with that model, we still had all kinds of questions. Which containers should be deployed together? If you had something that was stateful, like a database that was containerized, how do you have persistent storage for it? How do you scale it across servers and racks and regions and data centers and clouds even for a multi-cloud strategy? How do you control which containers can talk to one another and which ones should not talk to one another? So there are a bunch of questions that came in there with that simple model that couldn't be addressed with just the earlier tools. So along came this thing called Kubernetes, and I used to stop and ask if everyone knew what Kubernetes was. It's the hottest thing on one of the hottest things on the market right now. Originally developed by Google. Red Hat's actually the #2 developer of Kubernetes right behind Google, and we actually share or co-share over half of the SIGs upstream. So there's a lot of Red Hat engineering power that goes into I'll talk about Openshift a lot, but not just Openshift, but Kubernetes itself, because everything that we do, we try to do in Kubernetes first, unless it's something that's just very, very, very specific to Openshift, the way we did something early on. Google gets a lot of credit, and they deserve a lot of credit because they were the ones that created this. But it's not just theirs anymore. It's not just Red Hat either. There's tons and tons of contributors out there. It's pretty. It's exciting and impressive to see how the community has embraced this type of project and the momentum that it has.
How is it different from Amazon's ECS or Fargate? I know both are competing,
Yeah,
and
so
AWS is also trying to catch up with
so Fargate is a little bit different. That's early on, so I wouldn't say too much about that right now, mainly because I don't know enough about it to speak to it. But Amazon has what they call EKS, and as that is right now, it's Amazon kind of building and managing your control plane, and then you bring your own nodes and kind of add it to the cluster. So it's kind of like quasi 25% managed service where they take care of the control plane and you just kind of bring your compute capacity to it. But it's still Kubernetes, right? You can still do a kubectl something, that.
They invested so heavily on ACS and things like that. Now they are like in line with getting with Kubernetes.
Mm-hmm.
So is there a decision with respect to why it is superior, or is
Well,
it because
so what?
is
What
there
is
a
superior?
superior compared to ECS?
Because
Because they're trying to play catch up now.
yeah, well, and Azure and Google, well, maybe not Google because they were doing it early on, with some other aspects. It's you had like Docker Swarm, you had the Mesos stuff as well, and they all had momentum for a while, but the community ultimately decides what's best. The community is a big meritocracy, just like Red Hat is. So once more and more people got behind Kubernetes, it's even Amazon's not gonna fight completely against that. I mean, they can make a lot of their own markets, but why? If people are already using it and multi-cloud is becoming a real thing, for more forward-looking companies to look at and think about, why create any type of not momentum? What's the opposite of momentum? Barriers, things that slow you down.
Friction.
Well, we brought grace. He brings the word
Deceleration, yeah.
deceleration. So why do they want to do that? Any more than Microsoft does, any more than any of the other cloud partners that are doing that. Just makes good business sense for them. Because at the end of the day, they still want to sell you EC2 instances, right?
And to Nate's point, the idea is not about how many people are contributing to Kubernetes, but how many people are using it and deploying it and running with it. And I think that's
Lots of projects get really exciting, and lots of people do a lot of stuff with projects, but a lot of projects just become projects and toys.
They say projects.
Projects versus products, right? There's hundreds of real customers really using this in their real environments to run their real business. So, both aspects are important points to consider. All right, so along came this Kubernetes thing. So then we inject this into it, right? You have your developer, source code repo, CI/CD engine, spits out a container image. Kubernetes helps you decide which hosts those go on and how they get deployed in the environment. But it's still lacking, right? It's not enough. We still need networking. So when pod 1 and host 1 wants to talk to pod 2 and host 2, we need a way for that traffic to get from point 1 to point 2.
So how do people do for
There's been multiple solutions. So Calico, there's some other ones out there. Flannel, Weave, we use for our distribution. Openshift SDM, which is based on OBS. I would say the most popular open source ones are probably Calico and Flannel.
I mean, before Calico.
I don't know.
ask this guy. Right?
Yeah, ask Karthik. Because Calico was an open source project.
I'll
before it
do
was,
my plug when I come on. So,
Okay.
yeah.
Yeah, well, he'll probably get a little bit more to the networking stuff when.
Actually, I won't, but if I ask you, I'm doing a plug since you asked the questions.
There you go.
Thanks for the segue.
So it's still not enough. We need an image registry, right? So we're spitting out all these container images. They're getting deployed onto the cluster, but we want to maintain history. We want multiple versions to be able to roll back if we roll out a bad version, for instance. We need metrics and we need logging, right? We need developers to see what's going on with their applications. We need to see if there's abnormal behaviors going on so they can adjust, make changes, push those changes out there quickly and efficiently. We need application lifecycle management. We need those deployment and build techniques that we talked about earlier for developers to worry about writing their code, not actually building and dealing with all the nooks and crannies and knobs and bells and whistles to get the code deployed. We need application services, the XPath type solutions. We need databases as a service. We need message queues as a service. We don't want people to have to spin these up in all of their own environments. We want people to just say, I need a database. Let me run this little Ansible playbook, create a binding, and all of a sudden I have access to my database or my new message queue. We need a lot of stuff, right, in order to make this make cloud native application development a frictionless. Is frictionless the right word? Frictionless. friction this thing, in reality for these environments.
It's the best slide, by the way.
I'm a big fan of the most interesting person, the man in the world, and I'm also a big fan of OpenShift and Kubernetes, so they kind of went hand in hand. This was very late when I put this meme together, so the words are lame, but I couldn't resist. All right, so I already kind of gave this away. So normally I would ask who knows what Red Hat OpenShift is, and half the room would be like, I know this, and that's usually the Red Hat people. And the other half would be like, I don't know what it is, and then I would call you all liars because you actually all do know what it is. OpenShift is Kubernetes with a bunch of pluses on top of it. So those are all the value adds that Red Hat ships beyond what you would get in the core Kubernetes product. It's not a fork of Kubernetes. It's everything you can do in Kubernetes, like I said earlier, except some of the alpha things you're going to be able to do in OpenShift. If I want to do a kubectl, get pods, still works in OpenShift as well. So that's, if you ever hear that, then you can send them to talk to me and I'll have a teak. Stand in front of me while I say
And I'll point right back to him.
Yes. So OpenShift itself is based on containers and Kubernetes. In the beginning with Kubernetes, it was all Docker, right? It was basically hard-coded in. If Kubernetes wanted to do something, it made calls out using the Docker daemon and Docker tools to go and do its things. And now the movement is more towards cryo. So the container runtime interface that the community went back and fixed Kubernetes with would allow us to plug in containerd with, for Docker, OCI for OCI compliant images, Rocket, if you wanted to use that for your runtime. It makes it more pluggable, just like we did with CNI and CSIs coming in here as well. So OpenShift itself, from the platform perspective, we don't really care what infrastructure you run it on. If you want to run it on OpenStack, that's great. If you want to run it on Amazon, that's great. If you want to run it on a little bit of both, that's also great. Any infrastructure is where this is meant to run because, again, we don't want friction with the infrastructure choice either. But OpenShift itself is focused on those three middle layers, right? So the container host, the Kubernetes piece, the container orchestration and management, and then the application lifecycle management, which is, oh, there it goes. Those two middle layers, the blue and the blue-green, are what really kind of accelerate and enable the cloud-native application developments and environments. So, we'll go through all of these, but just to call a few out specifically, service discovery, right? We want a way to discover newly deployed or newly undeployed or newly scaled up or scaled down services automatically. So we don't have to know what pod or what container needs to talk to what container. A routing mechanism. So you can have the most awesome application in the entire universe running in this cluster. And if you don't have a way to get traffic in from the outside, then it's useless as anything I could possibly imagine. So a routing mechanism to get that.
Thank you.
I mean, I thought I said something funny. I was like, wait, that wasn't one of my jokes. We'll be another. So the routing mechanism is getting that traffic into the cluster and controlling that traffic. To another one of your questions, being able to do some traffic shaping and traffic modeling, move 10% of the traffic to the new version of the application, for instance. The monitoring metrics, which we talked about before. If your developers can't see what they're who's using their application, how they're using it, how people are clicking around, then they can't adjust on the fly. They can't make those quick changes to deliver faster. Other pieces, multi-tenancy, making sure certain services can only talk to other services. Service 1 for development team 1, we don't necessarily want to talk to service 2 for development team 2, and so forth. And then the application lifecycle management pieces, the deployment, the build components. That's what we'll get into here in just 1 second. So at the end with that whole platform, and usually I spend like 4 hours going through the details of this and deep dive, so I've spared you guys from that today. But at the end of that, you get this your full polyglot platform, right? So depending on your language, your runtimes, your middleware, your third-party images that you're bringing from partners, the Docker images that you guys are creating yourself, it gives you that platform to run them all quickly and efficiently. And I always call this out, virtually any Docker image out there. Should change that to say OCI compliant image out there. What does the I stand for? Doesn't that stand for image? So am I saying OCI image?
Open container.
Initiative.
It's like RPC calls and NIT cards.
Initiative.
So it's NIT cards is my big pet peeve. So virtually any OCI compliant image out there, we put some security constraints inside of OpenShift. We don't want you to run screw, for instance. We don't want you to run privileged containers. You can turn that stuff on, but we don't want the majority of development teams to do that because that's generally not good for the at least for the production environments. So. And you're going to see us run about. We have SC Linux disabled and everything for the demo. It's awful. You guys work with it. You have to show. I spent like an hour this afternoon, and I'm like, SC Linux was just beating me up left and right. So I shouldn't say that. SC Linux is awesome. Never ever turn it off, unless you're doing something that's like an alpha thing. And we won't talk about this because this is more of the platform architecture with all the pieces. So we talked about the platform, right? This is what enables this cloud native application runtime and build environment. But how do we actually build and deploy the applications themselves, the container images onto the platform? And there's a bunch of methods to do it inside of Kubernetes and Openshift, but the three we tend to talk about, there's multiple branches off of these, are the three you see here right now. So deploy your source code, deploy your binaries, or just deploy your container image. I don't like slides that like expose stuff, so I just put it all up there to begin with. So deploy your source code, we use something called sourced image, right? This is where we will take your source code that was committed to your Git repo from your developers. We'll take one of our builder images or builder image that you guys supply that has your runtimes, your compilers, your build tools, whatever you need on it, and we'll essentially merge those two, spit out an application container that's running your application code and deploy it on the platform. So with this method, no one's worrying about more complex CI/CD pipelines. No one's worrying about build processes. Developers are doing commits. There's webhooks and they calls over Openshift. Said, hey, here's a new push event. Openshift kicks off a new build, deploys that container image onto the platform if you have the right triggers set up, right? You could do the build process where it just builds new applications when people do commits and doesn't deploy them. So maybe you have someone that wants to go in there and just do a quick little check on it before it gets deployed to production. And then one of your DevOps people says, this is good, kick this out the door to the production environment. But that can also be automated fully end to end. The second kind of main vein is app binaries. Using similar source image methodologies. So build your binary outside of Openshift, whatever your current processes are. We'll still take what we call the builder image, but it probably just has more of your runtimes on there instead of all your build tools. Merge those two together, spit out a container image, give you the choice to deploy it on the platform. Of course, this one doesn't do the exposition. Or just deploy your Docker image. Build it on the outside, hand it over to Openshift, let it take care of the orchestration, scheduling, and lifecycle management of that container image. There's multiple strategies, like I said, that branch off here. There's pipeline strategies. So you can create this big, awesome Jenkins pipeline. Say, here, Openshift, here's my Jenkins file. Openshift will spin up your Jenkins master, spin up your slaves as necessary based on that pipeline, and do all your builds for you without having to maintain a separate Jenkins infrastructure to do those types of builds. You can do a Docker strategy. You have a Docker file. You don't really want to handle building it. Just give the Docker file to Openshift. Let it build it. And then there's custom strategies that you guys can use as well. So it's super, super flexible for how you want to build and deploy these cloud native apps.
OpenShift compatible with competition with Packer.
You can actually, I wouldn't say it's in competition. I actually did a demo for a customer where they were using Packer to build.
Do the same.
You can use Packer as another tool on top of OpenShift. Packer can build like virtual machines. Can Packer build container images? I don't know. I've never used it for that.
I think so. I'm not sure.
I don't know. I did a demo. I put something together for a customer where they were using Packer to build their virtual machines, and they wanted to run Packer inside a container on OpenShift, so you just feed it all the information and let it use your KVM and everything running inside that container to actually spit out their virtual machine. So it's just a tool that could run on OpenShift. And if Packer could build container images, those container images could be deployed on OpenShift. That's just the deployment piece.
It does have a Docker builder.
Okay. Yeah. Thanks.
So when you mention build source, is it something similar to serverless Lambda deployments, or it's totally different?
No, serverless is more, you just put your code in there and it just gets magically executed by a container somewhere in the back end, but you just don't know anything about that container.
It's totally different.
Yeah, it's pretty significantly different now. But the frictionless aspect of the source image build process is that a developer is still just writing code. They're still just putting it into the repo, and then something gets built and runs based on that code. You have a little bit more control over the runtime of the environment using something like this versus like Lambda or whatever the other ones are going to be called in the different public cloud environments. All right, so we know we need to move faster. We know why we need to move faster. We have this awesome platform that allows us to move faster. So now we have this stuff deployed, right? So we have this application, right? It has two services. It has a front end and a back end. Eventually the front end is going to have to talk to a back end for obvious reasons. So we have this thing called, services or a service layer inside of Openshift. And the way I typically describe it to customers is like this automatically configuring internal load balancer with a little bit of service discovery on the side. And this just really allows us, when we have that front end that needs to talk to the back end, the front end container doesn't need to know pod, back end pod, IP1, IP2, IP3. It's just going to talk to the service, which allows it to talk to those three pods and load balancers.
Kubernetes service and OpenShift service are identical?
So more or less, we provide the overlay network with Openshift that Kubernetes doesn't provide necessarily. The services inside of Kubernetes are what we leverage to do a lot of this. But you still have to have a network that can talk between hosts, whether it's a Calico CNX type solution, whether it's an OpenShift SDN type solution. You still need that other piece in there. Because with our implementation, again, without getting nerdy and going into the technical details, it uses probabilistic IP tables rules. So if I go in there and dump the IP tables rules on a node for this service name, I'll be able to see all the pods that are sitting behind that service and the probability that we'll hit pod 1, pod 2, pod 3, pod 4, so on. So that's all east-west, right? And it's fairly coarse in that I can't deploy. And you see 3 backend pods here. I can't deploy version 2 of that backend pod and have the front end send 10% to version 2 and 90% to version 1, service to service, that east-west. This is where what Karthik's going to talk about. Istio takes this type of thing to the next level and allows you to do more traffic shaping, intelligent routing, and circuit breaker type activities for all of that east-west communication inside the cluster. The other magic piece that OpenShift brings to the table is what we call routes. They're horribly named because they're not routes, they're not routers, not as most of us would think they're load balancers, right? So out of box, it's HA proxy. This sits up there as this route object. So when I developed Nate's new application that's the hottest thing ever running inside the cluster, all I have to do is go and create a route object in OpenShift called Nate's hotsnapever.redhat.com. And as soon as someone goes from their device, they hit that URL, it's going to load balance that traffic directly to the pods based on the service mappings as well. So very similar to how it works east-west between front end and back end, or service 1 and service 2. The routes also work to get the traffic in from the outside, balancing it to whatever service it's mapped to.
So what kind of load balancers besides round robin?
You can do source IP, round robin, and what's the third one?
Weighted.
What is it?
Oh, it's weighted pods, like you can always configure 70% goes to this part.
Well, there's that, but then there's 3. It's round robin, source IP. I don't know. I'll look at once I'm done presenting. I'll look it up.
I know what it is. The third one, I don't know.
It's somewhere in my I'll get it.
Something least, right?
Least connection. That's it. For all the other Red Hat. You should get an extra thing in there. So
Isn't there one coming out to what is available? What is available?
What is available for?
I mean, a load balancer that says what's available.
Well, then, yeah, the load balancer is always going to look if one of those pods is down or it's failing readiness probes, then it's not going to send any traffic to it. So we do have liveness and readiness probes built into the platform that'll watch that back. So, and you can also, if you have F5s in your environment, you can use F5s in place of the HA proxy load balancer and integrate those directly with the SDN. I'm sure there's other solutions that.
Talk about Istio and how it's coming along for Ingress.
And then the last thing I'll talk about here before we start to shift into the Istio conversation is the other aspects of routes, and I alluded to this earlier. When we're deploying two different versions of the application as a whole, not as a specific service of the application, but 2 versions of the application, we can start routing certain amounts of traffic over to application version 2 from version 1. The east-west communication, I still can't control those percentages without something like Istio. But at least for the north-south, ingress traffic into the cluster, you have that capability with OpenShift, literally a couple clicks of a button to start sending that traffic as appropriate to the new version of the
Something I'm
application.
really confused on is when you get the ingress packet, it has to go to a load balancer. And so it always goes to the same host where that load balancer is, and it goes to the other host from there.
Yep, so it goes over the,
Is there something that that you can have a load balancer like engine X extra?
we use, so we use HA proxy, not Nginx. Those would kind of be analogous in a way to software load balancers. So the route, we'll call it the route right there. So that route, the router is running HA proxy. It's running on the platform. So it's running as containers or pods within Openshift. So you have something on the outside, whether it's an F5 or another HA proxy or Nginx that has a VIP. So if I go to star.apps.redhat.com, it's always going to send me to that VIP for this platform, and then based on the URL, HA proxy will decide what pods to send it to.
So like
based on service mappings.
the service A and service B, they're on one host.
They could be, not necessarily, they could be spread across 50 hosts in the cluster. Because all we're doing is targeting a service, which is.
So you have to have a load balancer where it says route.
We provide that load balancer. That's the HA proxy load balancer that comes with Openshift. Right? So you need a route. You need either a load balancer to get to.
Load balancer to
go to our router. But once you hit that router with a URL, we know where to send the traffic to across all of those hosts that are running in the cluster. So you could have a service with 10 pods sitting behind it because you've scaled up to 10, and those 10 pods can be across 10 different hosts. And that HA proxy load balancer will, depending on which host it's going to hit, based on the routing or the policy, the load balance policy. So round robin, least connection, source IP, it will decide which one of those it's a front end back end configuration in HA proxy, right? So our router solution with the default template just does 80 and 443. If you want to expose non-HTTP HTTPS ports, you could do it with a custom router, but you're generally going to do like the port or extra IP type solutions with Openshift from the nodes themselves.
Can the client have their own load balancers and stuff using their own configuration?
HA proxy works pretty darn well, and it scales pretty darn well, and some of our biggest customers just use HA proxy, either with Openshift SDN or a third-party solution. So it's not your mama's HA proxy that they're going down. It's been tweaked and customized by our scaling performance teams.
If they are the client globally and they want to do a partnership, for the users to close this.
Sure. We didn't.
Happens all the time.
We didn't think about that. Sorry.
No, if they want to connect without the users to close this.
You'd have your GTM would have to really create that type of logic and then send it to the nearest set of Openshift routers that the cluster places to. That's definitely outside of Openshift's capabilities, though. So lastly here, before we turn it over to Karthik, it kind of shows you where we were a few years ago, where we're at now, and where we're moving to with the introduction of Istio. And the thing to take away from this is we want to get all of these requirements and capabilities that typically live in the application layer, get those out of there. We don't want developers to have to worry about circuit breaking and everything else, depending on what runtimes they're using. We want those to be part of the platform or part of some type of shared service that multiple applications can use. And that's, you can see going from 2014 to next, the amount of services that are showing up at the platform level to really enable these cloud-native applications, development of cloud-native applications has grown quite significantly. So Istio is some exciting stuff. It's still a little bit wrong in some cases. It's very early on, but it has a lot of potential. And you'll see a lot of stuff coming in Openshift Kubernetes for that real soon.
So current one supports the ability for the containers to be deployed. Because the Kubernetes, you can create like multiple containers type device, and you can say like you want to run like 2 or 4 or 6, whatever it is. Like you want to put in a rule that a particular container is running on a particular pod. I don't want.
A particular pod is running a
Let's say
particular host.
application A and application B should not be running on the same pod.
Yep, those are actually built-in primitives for that affinity or anti-affinity, depending on how you label
So we
the.
can create.
Yep, and you can get custom with your node selectors and taints and tolerations. It's a pretty mature scheduling mechanism in OpenShift and Kubernetes now. Cool. All right. I'm gonna turn it over to Karthik to do some Istio talk and demo. Let me stop sharing here real quick. Can I plug your?
Okay, good. You guys, I guess who's on Zoom, so I hope you can hear me okay. If not, someone please let me know. Great. So Nate kind of walked you through quite a bit of OpenShift, kind of what it provides. I'm going to assume you guys already knew that I was actually going at a much deeper level. We'll try and figure out how we can speed up a little bit. So my name is Karthik. I work at Tigera. Tigera is one of the companies that's been working on Istio since well before the launch. So we partnered obviously with Google and IBM, but Red Hat is also a contributor and there's now obviously there's a lot of companies working on Istio. Tigera is sort of known for a number of flagship projects, including Calico. Thanks for the plug. I'll talk about do a little bit of a plug for Calico with OpenShift when I get to the demo. But focus here is on Istio and what Istio brings to the table. Given that all of you are sort of, I'm going to make the assumption you understand OpenShift. I'll do a quick sort of here's what OpenShift is, but I'm not going to focus there. But focus on the service mesh and what it brings to microservices deployments. As what the concept of a sidecar proxy is, and in fact, in my demo, I'll sort of go into what that looks like in reality. Common use cases. My main focus today is on how can you use a service mesh. I think a lot of us in the community think, especially in the Istio community, think to jump into the details of, hey, here's pilot, here's mixer, here are the different components, without giving users enough of a perspective of how to actually use it. So when I go to customers and users, I get this sort of look in their eyes like, oh my God, there's so much happening. And not enough focus on how do you actually consume Istio. So the focus today is going to be on using Istio with OpenShift. And so most of the time here is going to be on the demo, right? How do you get it deployed? How do you use it? The different use cases. And if you have time, I'll go into the Istio control plane. If not, there's lots of content and webinars and meetups from the Istio community on the different control plane components. And specifically, how do you get started, right? So as Nate pointed out, Istio is emerging quite rapidly. That said, there's nothing that prevents you from having Istio deployed as part of the OpenShift deployment in one test namespace, in one test project. You don't. It's perfectly fine running in this little corner where you can play around with it, and I'll sort of walk you through how you can get started with Istio. So you don't feel intimidated, right? So that's my main focus here. I'm going to assume that you guys are all familiar with sort of microservices deployments, you understand containers, pods, what Kubernetes and OpenShift are. And I'm also going to assume that you're familiar with traditional open source concepts, which is, release early, release often, build fast, break things, one step backward, forward, right? So I'm going to take that based on assumption. And so I'm not going to introduce microservices. I'm going to assume you guys all know what microservices are, the microservice backend. You've moved off of traditional monolithic applications to now little microservices applications with well-defined API endpoints, which communicate over each other on top of a platform like OpenShift, right, which leverages Kubernetes for the runtime with all of the additional value that OpenShift provides for the build. And so over the last few years, last 2, 3, 4 years, a pattern that started to emerge was this concept of a service mesh. And along with the service mesh, there's a concept of something called a sidecar proxy. And basically the concept is this. If you're an application developer, you don't want to worry about all of the common issues you deal with in the real world, like traffic management. What happens if this application fails? How do I redirect traffic this way? how do I get a new canary style deployment if this breaks? I want to try out new versions of software where I can redirect a small percentage of traffic that way. I want to take care of things like authentication, authorization, encryption in the real world. And as a developer, very often developers are not the best people to be worrying about things like certificates and are they being generated the right way, right? Dealing with other things like how do you monitor it, what's the performance like, how do you troubleshoot. And a lot of these things have been offloaded into this little thing called a sidecar proxy. And containers and like specifically how Kubernetes and Openshift enable containers, which is the concept of pod, have made this really easy. So now you can attach this little sidecar container to your application container that takes care of all of these functions, and this can be inserted at runtime. So your application developer can focus on building your application, your business application, and leave all of this other stuff to this sidecar container that can be attached. And so you get all of these functions for free without having to have your application developer go in and say, hey, I want to see what happens if my load is 80% and then I need to redirect. All of this is stuff you get for free. And so that's the concept of a sidecar container. Specifically, this logo I'm showing here is a sidecar proxy called Envoy, which is used at Lyft, and they open sourced it about September of 2016. So it's been a year and a half. And so this is something that they use in production. There's other proxies available as well, but in the Istio community, Envoy is like the de facto standard, and there's more sort of evolving. But Envoy has some very cool characteristics.
On board with Istio.
Stay tuned. I'm coming to that. That's what I'm welcoming. Give me 2 slides. I'll get to that. Yeah. So Envoy is really the sidecar proxy that you attach to your running application container. One of the really, I think the most valuable features of Envoy is its programmability. Literally what happens is when you attach this next to your application container, Envoy inserts itself in the data path. And all traffic out of that application container is redirected through Envoy. So now Envoy can decide what to do with that traffic. And the way it does that is by having a set of programmable APIs that lets some other control plane tell it what to do. And in the Envoy community, we call it the XDS APIs because there's route discovery, there's listener discovery, there's a whole bunch of sort of discovery protocols. And Envoy simply says, here's my, if I need to know how to route traffic, I'm going to look up my routes, and my routes are going to tell me how to route traffic, right? But something else is programming the routes. In the meantime, I am seeing all of the data flows. So I have complete awareness of what the state of the application is, how long the response is taken, if I send traffic different ways, and all of this data is being collected, and something can leverage all of that data to give this global perspective of your deployment, right? And what Istio is a control plane that works hand in hand with this data plane to provide that, first of all, this control of all of this data that's being collected, but then to program the individual data plane sidecar proxies to tell them what to do for a given application, right?
Istio works with Envoy. Can it also work with the Nginx as a sidecar?
Yeah, absolutely. So the question is, Istio work and Istio work with other proxies? And absolutely. For example, Nginx has recently released something called Engine Mesh, which is specifically focused on this market. Historically, there have been other data plane proxies like Linkerd, which have now they've sort of evolved that into this thing called Conduit. There's sort of different proxies, and there's more coming all the time. But within the Istio community, Envoy is sort of used as the default proxy. Certainly, if you have a different one, you can plug that in. Now, Envoy itself is a very lightweight, modular, really nicely written piece of code. And what you'll find is the memory footprint of that is very low. It's about 10 to 12 to 14 megabytes, depending on how you build it. But Istio builds this as something called Istio proxy, and because it's so lightweight, it can run as a sidecar within the pod itself. So it means it can share things like volumes and secrets and other things that are in the pod namespace. And so that concept of running something alongside the application in the pod is a very powerful concept. Okay? Now, we have this Istio control plane here, and Istio has a number of components. We have kind of talk about that, but fundamentally the concept is this: there's a few functions that it performs. You can use this control plane to program the individual data plane proxies in terms of what they should be doing. You can collect telemetry data from all of them in terms of real-time traffic patterns to analyze at a global level, so you know, hey, I'm seeing performance issues here, I need to redirect, or so that's sort of one function, which is traffic management, and I'll show you in the demo some of the different kinds of traffic management scenarios. The second sort of core function, in fact, maybe I should just switch to this and talk about some of the key use cases for Istio, or the sort of concept of a service mesh. One use case is observability, and that's an important use case because now you can actually look at what's happening in your service mesh without having to modify the application. The application is just in your business logic, whatever you need the application to do, but now you are able to trace your microservices. Why is my performance between this point and this point suddenly high for this transaction? Why, like what's my aggregate view? Where are my hotspots, right? Being able to do logging transparently. I'm not showing that in the demo, but there's, if you go to the Istio website, I'll point you where that is. You can actually get some logging as like between this microservice and this microservice and this pod and this pod. Here are the transactions that occurred. Here was the performance we observed, and to get some very in-depth logging without the application developer changing the application.
Can you turn the tracing off and on?
Yes, I'll show you how you can do that. Yeah, absolutely.
With Prometheus, what happens when you are using the logging here in the control plane? How does that intermingle with this?
I'll talk about that when I get to the control plane in terms of Mixer and the different adapters of Mixer. But the little thing you see in the middle here, which is this little adapter thing that I'll come back and talk about the control plane. But you can have different adapters, and that will tell you what you can do with the different sort of plugins you can have if you want. And fundamentally, so that's one use case of observability. The second sort of very common use case for service meshes is traffic management. They've referred to this multiple times. When you have multiple deployments, you can do blue-green style deployments where you have sort of different users going into different sort of versions of the application to see, hey, if I send them to this version, are they more inclined to buy versus this version where they're just looking around, right? So you can try out different sort of patterns there. You can style deployments, trying out the new version by redirecting one person of your traffic this way. And if it's broken, just fail that and send them back to the old version, right? If you have having things like circuit breakers, so if your microservices further down the path is having problems, there's no point carrying traffic all the way through your earlier microservices and then just to fail. You might as well fail early, right? So just having circuit breakers and other sort of traffic management aspect, retries, being able to do those retries automatically, deciding how many retries you do before you fail. And these are things that historically your application developers would have taken care of, maybe with some very manual, hard-coded imperative functions in your load balancers. And now you get all of that for free by deciding these rules at runtime. And I want to get to the demo because that will give you sort of the proof of the pudding, right? And the third very common use case with Istio is security. And this is something, and I don't want to understate this, this is actually a very critical use case because, for example, at Tigera, we're very focused on this zero trust model where we've moved past this model of perimeter firewalls and things in the middle of the network that used to sort of provide these very coarse-grained rules and very static to now a dynamic, orchestrated, declarative world, right? And you want to use multiple sources of identity based on and using authorization and enforcement at different layers in your stack, in your communication stack. But a number of things that Istio brings to the table is the fact that now you can assign a verifiable identity to your application, specifically a service endpoint in Kubernetes that says this particular service endpoint is being assigned this certificate, so you can verifiably identify that service irrespective of how many pods are running that service. And when it talks to another service in your service mesh, that you automatically get mutual TLS. so that both sides are authenticating to each other, so that they know that the person that or the service they're talking to is indeed who they claim to be. And so you use these certificates for things like encryption if you want to, and authentication authorization. So you actually have this MPLS between services. And all of this is being enabled by Istio. Istio has this concept of a CA, which is being renamed as a Citadel and expertise. And the concept is now these certificates are being generated dynamically. It could be certificates, it could be charts, it could be other functions. But essentially, you give this identity to your service instances dynamically, taking care of things like revocations and other sort of functions they need to do. But now all of this works in the trust hierarchy so that these services that are talking to each other know exactly who they're talking to and can leverage this for sort of identity and encryption and other sort of security functions.
Is that done with Istio or Envoy?
This is actually, all of this is done by Envoy because Envoy is a data plane. And what Istio does, CA, moving to Citadel, does is it generates the certificates, hands the certificates to Envoy, and Envoy actually uses those certificates to authenticate or encrypt or whatever else, right? Do MPLS specifically. And so Envoy is the actual component that's performing the function. Istio is the component that generates the certs for the.
And where does Istio and Envoy live?
Let me get to the demo. I'll show you how that works in practice. I have a security demo. Okay. And again, there's a number of use cases. I'm just capturing a few high-level ones. You asked about sort of policy in terms of how does Prometheus deal with this? How do other adapters sort of deal with this? And because your Envoy sidecar proxies alongside your application pod, it is intercepting all traffic. It has a view of all flows for that particular application instance. And it's collecting a whole lot of telemetry, yes, which it stores locally, but can be collected by a control plane, which in this case would be the Istio mixer. And so this telemetry is being sent back to Mixer, and Mixer has all of this now telemetry data that it can use for higher level global decisions. And I said, I haven't introduced Mixer yet, but this is one of the Istio components. So Istio has this global view of what the actual traffic profiles are that it can use in decisions. And it can use it with things like quotas. Does this user have this quota? Does this set of users or services have a sufficient quota? Have you exceeded your quota? Preconditions, integrations, being able to say precondition, if this happens, then perform this. If you start seeing your traffic, your response time exceed this, then start doing this. If you see this anomaly, then start logging your traffic. There are all kinds of things you can do, and it's all flexible. Prometheus is one example of sort of a collector that plugs right in, and I'll actually show that in the demo as well. And I don't want to understate this. I think Nate had mentioned the concept of the Openshift router, which is today HA proxy. But one of the things that's being very rapidly developed is the Istio ingress and egress. And there's a resource being defined in the Istio community called the gateway resource, which is, I would say, a much more expressive way of defining what an ingress can do beyond what Kubernetes provides the flexibility for. And so this is sort of emerging. So that's sort of a whole use case in terms of how you provide not sort of traffic into the service mesh in a given cluster, or even traffic leaving the cluster going to an external service. So if you had like a cloud service you're consuming for your application, right? And there's work going on, for example, right now in Istio, the focus is on east-west traffic, monitoring traffic, measuring traffic within the cluster. But now there's work going on measuring client-side performance as well, like client-side metrics. So you can even, there's a lot of work going on. So this concept of ingress and egress and the controls you can have with traffic coming into the cluster, traffic leaving the cluster, also give you some pretty powerful capabilities, including all of the other traffic management, security, and a number of other capabilities. API management is another whole completely different domain, but also a critical one that's sort of emerging in Istio as well. For example, the Red Hat folks have Freescale, there's RPG, historically you had this sort of parameter function that there's transformation of your APIs and traffic calls in, which now as you get more intelligence, there's more functions you can do, there's a lot more things you can build in. I think what you'll find generally as a theme for all these slides that I've talked about is that historically the intelligence that was in perimeter functions, centralized load balancers, centralized firewalls, centralized IPS IBSs, centralized API gateways, you see a theme here. All of that's moving to the edge. Now your compute host and your workload is where your intelligence lies. And if your Envoy proxy can do load balancing at a much more granular level with a centralized control plane, what's your centralized load balancer going to do, right? You can still use it maybe, but you have a lot more power now. And so the intelligence really is moving closer and closer to the application, and that's a profound industry shift that's happening. So let me switch to the demo because I think that will give you a much better feel for what I'm trying to talk about here. And what I have here is a Openshift cluster. Let me show you. Which I just got running today, so hopefully it's still running. Right now, not much running.
Can you increase the font?
Yeah.
And Karthik, I think that one of the points to make here is that you can do these policies across individual nodes, but how do you do it across an entire infrastructure?
Right. I'm sorry, I'll get to that in the demo. And because you, thanks for the plug on Calico. I'll, install. This is actually installed with Calico. Installing Calico with Openshift is a matter of about. I actually have like about 8 lines here. It's actually less because I wanted specific versions of containers. In effect, all you need is like these 3 lines, and you have your Calico running with the standard Openshift installation process. It just works, right? And you have a clean layer 3 IP network as opposed to typical overlay complexity. But let's leave. I'm not talking about Calico here. It's in your OpenShift Ansible host inventory file, which is how you typically you would install OpenShift using Ansible as an installer in OpenShift docs. But that's how you install it. It takes about 20 to 30 minutes. So I won't go through the install here, but I have this cluster running, right? And so given that this is running, now we're going to actually switch to Istio and walk through some of the Istio use cases. So I already have it installed. I actually downloaded the latest version. So the current version is Istio 0.7.1. Right now, Istio is on a very rapid cadence towards a 1.0 release. It was announced May of last year. In fact, we did that at BlueCon, had a demo back then. Right now, we're on a monthly release. The 0.7 release was the March release. So if it's a monthly release, 0.7, expect a 1.0 sometime around June, July, August-ish timeframe, right? But I'll come back and talk to the different components of Istio. The vast majority of Istio components are in what's called alpha stage, or even pre-alpha, so the alpha, beta, and GA. And so they have different symbolisms. I'll come back and talk to what that means. So keep in mind that all of the Istio components are in a fairly rapid churn. That doesn't mean you can't use it. There are sort of quirks here and there, and maybe even when we build a demo, we might encounter a couple of those. But one thing that I think Nate stepped out, this is actually running an SULinks enforcing. So yeah, that part is figured out. Okay, so let's do first install an Istio. Before I do that, in OpenShift, first of all, there's a few things. OpenShift sort of equates the concept of projects in OpenShift to what's namespaces in Kubernetes. So I do an OC create, I can type.
Make that top screen a little bit.
Yeah.
So kind of see it.
Can you see it now?
So, yeah.
Okay. Let's see, create.
Do you need name?
Sorry? No, it's fine. Yeah. Project Istio system. New project. Okay, and now I would, in OpenShift, like Nate was saying, everything runs in a security context. So anytime it sort of has this concept of least privilege, which is if you don't need to give things root, you don't. And That said, there are a number of components in Istio today, such as the proxy where you're intercepting traffic, right? Where you need additional privileges. So we actually have to set that for a number of the Istio components. So I will do that now. I'll show you what this runs. So basically, all of the Istio components, I'm giving it the right level of privilege. And basically, what this is how you do it in OpenShift. You run this OC ADM, and it gives it the right privileges in that. By the way, I know someone had a question on what does the OpenShift dashboard look like. Just a quick sidetrack. This is again to show you this standard Openshift cluster. I mean, you log in the dashboard, you have all of the build tools and whatnot. But here we focus on, you already built the application. Now you focus on the runtime part of it, right? So assuming this shows up, there you go. Again, this is your standard OpenShift dashboard, but we'll mostly be focused on the command line and then show you the Istio functions from it. Anyway, so you got the credentials installed, and then we will install Istio itself. So installing Istio is OC create -f install Kubernetes. And I'm installing the Istio auth version, which is the version where you are now generating certificates for your applications and using it, potentially using MTLS, depending on whether you want to enable it in the given namespace or not. Okay, already exists, right? Far enough. But for the most part, this should start, and we'll see that it's starting up a number of Istio control plane components within this thing called the Istio system namespace. And so there you go. So you have your Istio control plane running. Now, how do you actually insert the data plane, the envoy proxy, right? There's a couple of ways you can do that. So if you do this, historically you used to be able to do this the manual way, which is you would run this thing called Istio kernel and run cube inject -f. Let's see the samples. Sleep. I have a sample application which is just sleeping, right? And if I just do that, if you look at the manifest for this application, what you'll notice is the sleep application now has been attached with this additional thing called Istio proxy. And essentially what I've done is I've modified the application manifest to now have an Istio proxy running alongside it. That's sort of a manual way of doing this, because now what I'm doing is I'm taking this application YAML manifest and using this thing called cube inject to dynamically change that YAML to now have 2 containers instead of 1. And then you can launch that via OC or kube kernel, right? Which is one way. It gives you control over individual applications. But you may want to do it in a more automated fashion. And so there's another way you can do this. I actually have to go back and look at the command, because it's actually in the Istio docs. What I will do is use this thing called automatic sidecar injection, which is so there's 2 things I'm going to do. I am going to use a function in Kubernetes and OpenShift called as a mutating webhook, which is a form of admission control. And what this does, and this is a feature that is in OpenShift 3.9. It was because OpenShift 3.9 is based on Kubernetes 1.9, and this feature only showed up in Kubernetes 1.8. And what this is when you launch an application, Kubernetes gives you a function where you can say, I want to now, before I run an application, run a webhook to validate the application. There's sort of 2 kinds of webhooks. One is called a validating webhook, which is you can just verify if it meets all the requirements before you run it. And then there's something called a mutating webhook, where you can actually go in and change the manifest to add more annotations, add more functions. And so we use this mutating webhook. And so it requires a couple of functions in OpenShift 3.9. And in the OpenShift master, you will need to enable mutating webhooks, which is add these 4 lines here. And also these 3 lines. These are actually documented in the links I have at the end of the document. to enable mutating webhooks with Openshift, then you have to restart your master or your master Cube API server. And once you have that, you have your webhook running. The next thing you would do is you would do an OC create dash Istio sidecar injector config map debug. I'm just gonna do the debug version of that. And what that config map looks like is, if I show you that, is basically what I want to inject alongside the application. It just gives you a template for that, right? There's one more step I need to do, which is I need to sign the mutating webhook. So you can't just random people can't insert webhooks. You need to have it signed by Kubernetes, so Kubernetes actually trusts it. And so what we will do is we will essentially create a new YAML that will be signed by the Kubernetes CA. And if I show you what this looks like, essentially what this is I've now got this webhook defined. I have signed it by the Kubernetes CA. This is actually changing the next version of Istio that will be taken care of by Istio. And also I'm saying that match labels. So I'm saying any labels where the namespace matches has this label that says Istio injection equals enabled. I will now insert the sidecar proxy. So now I can go on a namespace by namespace basis and decide if I want to have Istio in use or not. So now if I run this, okay. Notice now I have this thing called the Istio sidecar injector that's running. It should take a few seconds. There we go, it's running. And now I can decide on a namespace by namespace basis if I want to have Istio injection enabled or not. The way I would do that is Istio obviously create. Label. Actually, I have to create a namespace. Let me create a test namespace. Let's see, create. Let's see, new project. Actually, sorry. Ooh, 45. Okay. And now if I do a OC, 45 Istio injection. And if I do a OC get S dash L. Essentially, it's telling me that I now have this namespace called foo45, which has this label Istio injection equals is enabled, right? So now if I launch an application in this namespace, so if I do a OC create -f samples, I'm just going to launch a sleep application, which is a simple sleep application while it's doing a sleep. You'll notice that when the sleep application starts, rather than one container, it actually has two. It actually has two containers in the pod. And once it starts, we can actually take a look at that pod to see what it's got. And in fact, there it is. So if I do a, let's see. If I look at the pod spec for that application, you'll notice there's my sleep application that's running. That's the application that what it's That's the user application. But alongside that, now have this additional thing called the proxy, this Istio proxy, which essentially is Envoy, which is running Envoy, which is now running alongside your application. This is the image for that, the proxy, the debug version of that, right, which is giving the additional data. And all of this is running alongside the application, but it'll only run on pods launched in namespaces that have this thing called Istio injection equals enabled. Which means you can have your production Openshift cluster, everything is going on in normal. You run Istio in this Istio system namespace, you enable this label on specific test namespaces, and you can play around with Istio to your heart's content. The rest of your namespaces are fine, Openshift is solid, right? And Istio, despite all the rapid churn, you can play around with it. What do you actually get from using Istio? Now let's get to that next section. By the way, let me pause. Any questions so far on anything I've talked about? All good. Okay. This is not too slow, too dry. I know I'm a little over time, I think, but you guys are here for Istio, right? Not for the raffle. Okay, cool. If you need to do a raffle, anyone say we need to do a raffle early in case you want to leave, let me know.
Depends on what the prices are.
I think this is the price, isn't it? So, oh, okay, cool. All right, so what was I going to show next? So some of the use cases for Istio. So now I've got this running. I also had a Istio. They have a sample application called Bookinfo, which is sort of a microservices application where you've got multiple sort of front end sort of product page for a bookstore or Bookinfo application with multiple sort of reviews version, and then sort of like different microservices talking to each other. And we'll explore some of the Istio functions using the sample application, right? So let's first start by launching this application. Actually, before we do that, we can even, Istio provides a number of add-ons out of the box like Prometheus, Grafana, Service Graph, and so I'll launch that. So and so I will first launch those add-ons. So for example, out of the box, these are the add-ons that Istio provides. Zipkin for tracing, Service Graph for giving you a service graph, Prometheus, Grafana. There's actually one for Fluentd and Kibana. There's one for Jaeger if you prefer that to Zipkin, but these all stuff that, okay, there you go, the services are running. And the next thing I will launch is an actual application. So if I do a OC create dash F, actually it's samples. Okay, and you'll notice that the Bookinfo application should be starting up here, and you got the Envoy pod injected alongside it, running in this full namespace. Takes a few seconds. There's some Java in there, which always makes things way more slower than it needs to be. Sorry for all the Java fans in the room. I'm not one of them. Okay, where did I forget? Check this. Oh yes, I forgot to give it the SEC permissions. Yeah. I forgot to give it the security context. So let me delete this first. Okay, so those are terminating. So in OpenShift, everything runs with least privilege by default. So for applications like this, where you have an Istio proxy, you need to give it the appropriate security context so it can do things like run things as root or give it the right privilege. And so I have a script for that, which is and what that is basically an OC-ADM command to say I want to give this privilege to these service accounts, right? So now that that is done, so let's run that again. Hopefully we have better luck this time. Nice thing in Kubernetes is things are relatively quicker, even though it's Java. For the initial Analyzing. Okay, good. So we are getting to running pods now. All right, so that's one thing that is done. Now let's access that application. So we'll see get service is how you would see what service running. And so, for example, if I go to Istio ingress, which is how you'll access the service, ingress is currently running on port 32265. So if I go to my browser and I go to .65 slash page, which is the entry point for the application. There's my Bookinfo application, which I just deployed. And the whole concept of the Bookinfo application is I have 3 versions of the review service. One of them has black stars. If I do a reload, it will see another version that has no stars. And a third version, for some reason, the cloud is slow today. I have a version that's red stars. So I have 3 different versions of the review service, and now we'll sort of use this here to do more advanced sort of traffic management and security and use cases. But that's the Bookinfo application running, right? But even before, let me actually start with observability. This is your application running, and obviously I can do reloads and whatnot. But now if I go to my services or the add-ons I launched with Istio, so let's start with 1. That's my Prometheus, is where I'm running my Prometheus add-on. I'm now getting sort of Prometheus data on application traffic. This is without modifying the applications. Another example is Grafana. If I want to look at Grafana and look at real-time stats, let me go to the Istio dashboard on Grafana. For some reason, my access to the cloud is really slow, unless you guys are soaking up some traffic. Okay, there you go. So here I'm actually seeing my transactions, and if I do a few reloads on this traffic, I'm not sure why maybe it's Zoom or something. My system is really slow. If I do, which is good because now I can get some traces via zip and see why it's really that slow. I didn't plan this, but that's pretty cool. So now if I go to my Grafana dashboard, you'll notice that I'm getting all of these stats on traffic patterns for my individual microservices fairly, and apologies for this being so slow. If my network connection was faster, you'll actually see it can move faster, but essentially I'm now getting detailed stats on individual microservices flows, east, west, and north, south into your cluster and between services in your cluster, sort of transparently. And I can actually go in and introspect individual flows to see what, how many of those are 200s versus 500s versus other sort of things. All of this data is being captured by the Envoy proxy, being sent to Istio, collected by Istio. And then Grafana is talking to Grafana and Prometheus are basically scraping this data and displaying it to you in this nice little dashboard. Your application developer hasn't changed a single line of code. All of this is transparent. Another example. So if I go to 32 search for 3 slash there's my service graph of the services which are actually running my application, real time, generated on the fly by Istio, and I can go in and click on one of them and say if my access wasn't this slow, or maybe it's my computer, I don't know. I can actually look at real-time stats and what my traffic flows are like. Again, transparent to the developer at runtime. This is really powerful observability that you get for free. And since my connections are really slow, I can actually go to the other, the Zipkin service. Oops, wrong port. and look at my traces to say for my product page service, find traces and let me know why it's taking so long. So I have something that it's taking 1.8 seconds. I can go back and trace like exactly where it's spending its time between which microservice and which microservice. So right now there's 1.674 seconds in the review service. Why? I don't know. Someone can go trace, but now you have this visibility, right? So you get this tracing information all for free. So observability is one core use case, and I'll sort of show you a very quick canary style deployment. So if I sample looking for view. So if I add this thing called what's the way I put that? All v1, route rule. So I'm going to create a route rule saying all v1, which is sorry, history of create. So I'm creating a route rule that says now send all traffic to version 1, which has no stars. So if I do a reload, the only version of the application I get is the one without stars. So literally all traffic goes to that first version of the review service. But now I want to do a canary style deployment, which is I will run a route rule reviews test v2, and what that looks like is basically saying match the HTTP headers of incoming traffic to see if the user logged in as Karthik. If it is, then send them to version 2 of the application. So if I'm logged in as Karthik, I get a special version. So if I'm not logged in to the application, I get the default version. But let's say I log in as Karthik. Now I get the black version. So now I can sort of redirect a handful of users to see what the behavior is. And all of this is sort of transparent to the application developer having to worry about this. Right? So that's one example of traffic management. Let me pause there before I sort of go deeper. I had another example on security for mutual TLS. And what else did I have? I had a couple of other examples as well. But before I go further, any sort of questions so far? Are you guys, I know it's like coming up on 8 o'clock, so are you guys sort of fading?
I have one question. Like in Zipkit, you are going through the details like radio of the traffic is going up. How detailed can you provide a solution?
This is standard Zipkin, which is essentially
They can bring it down.
essentially you're using trace headers in your microservices, which is all being inserted dynamically by Envoy, right? And your application hasn't done this. Envoy is now leveraging these trace headers, collecting the data, and sending it back to, in this case, Mixer. And Zipkin runs as a plugin into Mixer, so it's collecting that and displays that. How much detail you want to collect? I mean, there's obviously a default level, and then you can obviously add to it. But you know, like when you look at Zipkin, Open Tracing, Jaegers, and other alternatives, they all have different features. So it depends on the specific plugin you're using and how it's presenting that. But it's up. Again, the concept here is Envoy is doing the hard work of collection.
Yeah.
Istio is providing a nice little control plane and an interface for other plugins to use. Right? So it's sort of a system working as a whole, and then you have individual plugins build that.
If I want to, sorry, because if I want to, because I have to connect both in cluster and out of cluster applications, how do I send both of those to one Zipkin visualization?
Yeah, so let's come back and talk about mesh expansion. That's one of the sort of deployment scenarios being looked at with Istio. And in fact, now with Mixer, there's in the 0.8 release and the 0.9, there's now focus on getting client-side stats. And so everything from so SNI Master now exists in Envoy, but there's other things in the pipeline on how do you expand stuff outside of your cluster. So
But are they all along the lines of basically extending, running the sidecars outside the cluster?
Correct,
Okay.
yes, but for example, things like Mixer collecting client-side stats doesn't mean you need to have something running on your client. Obviously, you may or may not have access to the client. But again, you can get some statistics. Obviously, we don't have something running on the remote end that limits what you can do, but you can still collect data on this side, right? There's headers, there's sort of various things.
I guess I was thinking more back-end stuff, like having databases and whatnot outside. It's a different kind of measurement.
And this is, we'll talk
Upstream
about mesh
services,
expansion
yeah.
and as well as ingress
All
and
those
egress.
fit there.
Yeah, exactly. There's things you can do, and there's other things where you might need access to whatever the remote endpoint is, but there's still
Okay.
things you can do.
I guess connecting two disparate clusters together falls into the same category of expansion.
Correct.
Mesh expansion.
In fact, I have a slide coming up on exactly that, right?
Gotcha.
So this is sort of the observability use case, and I also showed traffic management. So that's sort of two scenarios I already shown. Let's go and talk about security. So right now, this booking for application, it's regular HTTP traffic. There is no sort of service identity verification. So let's create a couple of new namespaces. Full, let's call it full. Project, sorry. And let's go to another one called bar. And let's go to another one called baz. Right, so we created 3 new namespaces in Openshift, and let's create some applications in them. Chronicles. Okay. Oh, I forgot to do Istio injection. So I'm going to turn on Istio injection in a couple of them. So I'm going to label foo, and I'm also going to label bar. And that's sorry. And notice that I have foo and bar labeled with Istio injection, but bias is not labeled. So now let me, I need to run the application. I typed it in. F, sorry. And I'll also create another HTTP bin. Likewise, I'll create this in bar. And same thing in baz. Okay. And now if I do, if we run this, I'll show you what this command is. So basically this is simply doing a curl from one service to the other, and all services should be able to talk to each other. So essentially I'm getting a HTTP 200, which is sleep.tool, able to talk to HTTP bin and foo and bar, and so all the different services are able to talk to each other. But now what we'll do is we'll create a security policy that says we want to use MPLS, and only things that are authenticated should be able to talk to each other. And the way we do that is by saying we create this policy in Istio that says for namespace foo, I'm going to enable MPLS, which says peers only accept MPLS. So if I'm mutually authenticating the remote end, then accept. Otherwise, deny. Right? So if I do an Istio couple, okay, and what's the CRD for that? Let's forget this already. That's okay, it doesn't really matter. I was going to show you what the policy looks like, but the policy has been applied, right? And so now if I run that same command, what you'll notice is, first of all, we have these services running in full, which are now running with this Envoy sidecar. We have these services which are running in bar, running with the Envoy sidecar. But these services running in BAS, not running with the Envoy sidecar because they don't have Istio injection enabled, which means in theory, if this works, access to those should fail. So notice that the foo to bar works, but BAS to foo and BAS to bar does not, because you no longer have the certificate via Envoy and Istio in those namespaces. So in effect, now you're using virtual TLS to authenticate both sides of the connection, and you're doing it on a namespace per namespace basis to say, I'm going to allow this and do sort of virtual TLS, right? So another sort of key use case. Now, very quickly wrapping up and sorry. Go ahead.
Quick question.
Yeah.
Can you talk about authorization on that? Right now, you're just doing very coarse grain. How
Yes.
fine grain can you get?
Yes. In fact, that's a great segue to things like Calico application policy, which we have out there. It's actually on GitHub you can play with. I'm actually going to skip over the Istio control plane, but the thing that you specifically asked, so in the Istio control plane very quickly, there's pilot, which is how your users interact, provide configuration through pilot, mixer, which is what's collecting all the stats, provides adapters, or you can have adapters plug into mixer, and then auth, which is what is generating the certificates. And there's this component called CA, which will be renamed Citadel, which is generating certificates and doing authentication and potentially authorization. Now, authorization can happen in different parts. You can have sort of controls in Mixer that specify if this sort of preconditions happen, then I'm going to have a rule that says I'm going to allow this or not. So you can have different sort of flexibilities. But specifically in auth, Istio has a number of RBAC controls built in. So specifically, Spike, one of my colleagues, was the co-chair of the Istio security working group, has been working with others in the Istio working group around having a set of very in-depth RBAC controls and how you would provide authorization and different auth controls in terms of what is allowed, what is denied, and leveraging various elements of the identity, whether it's a spiffy identity spiffy, but you're assigning identities to the individual services. And so Istio out of the box has a built-in RBAC mechanism, and there's sort of the ability to add additional RBAC mechanisms as well, sort of pluggable RBAC as well. And that's something that has been worked on over the last few releases, and now and that's continuing work. In fact, Spike and others in the security working group have been pretty active in that space. So there is a whole lot of flexibility in terms of the kinds of RBAC controls that you can have tied to Istio auth and specifically the CA function, and what sorts of functions need to be enabled, leveraging the strong identity for the application. Now, there's a whole lot more. At some point, maybe we'll have a more in-depth session on that. This is actually a good plug for one of the, I was helping with this a little bit, where in the Cloud Native Online Meetup group, we've got this Istio Primer series going on. We started that about a couple of months ago, where I did a similar use case meetup. Then there was one of the guys in the team did one on the Istio architecture going more detail, and now we have each of the working group leads going into different deep dives. And Zach Butcher did the pilot for a deep dive, and there'll be a mixer deep dive, and so we'll go much deeper into the individual components. Honestly, there is a lot going on right now in each of the components. I forget who had the question on, I think it was you had a question on being able to connect outside the cluster. So mesh expansion is one of those use cases where you might have virtual machines and other services outside the cluster. and being able to expand Istio outside the cluster. There is a whole lot of work going on there. Similarly, multi-cluster is another scenario, not just a single homogeneous cluster, but multiple different kinds of clusters. Doesn't have to be Kubernetes, it could be other kinds of clusters as well, VCOS, Docker, a whole bunch of other sort of clusters as well. And I am not doing the Istio community justice because there is a ton of innovation happening right now. What I gave you in the last 40 minutes is a very quick walkthrough. My biggest sort of where I've been spending a lot of my time is sort of, especially users and operators get intimidated by the amount of churn that's happening in Istio right now. If you look at the vast majority of projects in Istio, most of them are in alpha stage or in dev stage pre-alpha. And what that means is in alpha and pre-alpha, APIs can change, there's no guarantees, there is no support. But as we approach the 1.0 release, all of these projects are gradually going to evolve into a beta and then into a stable state. And if you actually join the Istio dev Google group, you'll have access to a document that talks about what the maturity of each of the individual components are. Keep in mind, the vast majority today are alpha or development, which means don't expect any API stability. But it does not mean that you can't use it in like test clusters, test namespaces, test clusters, even test namespaces in production clusters. Because from a lot of the users and customers I've talked to, just being able to use it in a test cluster gives them a whole lot more value than having the developers build all of these functions into the apps, right? Yeah, so that's the quick point here. Don't be intimidated by Istio. This works. There is actually a few documents. First of all, a quick plug for our training. We actually have a one-day training class where we walk you through different use cases of Istio, troubleshooting it, a whole bunch of labs. If you're interested, obviously we have a Slack channel for Project Calico, including an Openshift channel, a Kubernetes channel. Istio and Calico application policy. This is something we announced at KubeCon in December. And if you go to the GitHub link, it talks to how you can actually combine Calico policy with Istio. So you actually have host enforcement working hand in hand with Envoy being pod level policy enforcement, and sort of a unified policy model going across both, where now you can specify application level constructs, like I wanted to allow this application to do HTTP gets but not puts. But use that hand in hand with Calico policy, which gives you a lot of host level controls independent of the pod, but also a lot more sophisticated feature, which is not the focus of this meetup. Maybe we can talk about that somewhere else. Also, the Red Hat guys have been, like, for example, James Faulkner, there's a few other guys who've been working on some very nice labs. So if you go to some of the links I've shared here, and I'll post the slides on the meetup page, you'll find some good content there as well. Take a look at James Faulkner's blog post here. He talks about how to do the Istio auto injection. Now, keep in mind, I did this with Calico, so a lot of the workarounds there, some of that was specific to the Openshift SDN thing, but some of those are also Istio specific. So there is some good information there. He also has a lab coming out at Red Hat Summit. If you want to join Summit, we also have some nice presentations there. And the Istio community, everyone's willing to help. Join, post on Istio users if you run into problems. Try it out, give us your feedback, explore. This is community, this is open source. Come join the community and let us know what sorts of capabilities you need. Any other sort of questions, comments? We should do the raffle, I think.
Okay.
Yeah, still a few people. Sorry,
So
was there a question? Or?
Yeah, is this recorded?
yes.
This is recorded, yes. If you haven't messed up.
So one thing, we're also having a birthday party at Red Hat Summit, and also we would really like your feedback. But also, if you do want a recording, if you can do the sign up sheet and just give us your email, since we don't really get the information from meetup.com. So if you have a moment, just come up here and do it. Also, did anyone not get a number for the raffle? You needed one, right? Okay. No, you don't get a number.
Or a webcam.
You definitely don't get a number.
Okay.
I was gonna make a comment, but since it's being recorded, like everything else.
Should we stop the recording?
Yeah, I'm gonna start recording now. We don't need to watch the rest.